Welcome to another edition of RCE. Again, this is Brock Palen. You can find us online at rce-cast.com. Also, feel free to jump over to iTunes or your other favorite podcatcher and be sure to leave a review. This makes the podcast more visible to others. There's also a nomination form on the website where we've recently had some contact from users giving recommendations of other places, and actually the show today is an example of one. Once again, I have Jeff Squyres from Cisco Systems and one of the authors of OpenMPI. Jeff, thanks a lot for your time.
Hey, Brock. It is a busy time for everybody, right? So as we're recording today, there is a Euro MPI conference going on. There's an MPI Forum conference going on. They're going to go hand in hand. We got supercomputing coming up in a couple of months. What's going on in your neck of the woods?
So I will also be at Supercomputing. Drop by the Michigan booth and come see some of our recent advancements and hardware we've put on the floor. But next week, probably about the time this goes out, I will also be at the Frontiers in Computing and Data Science, a little mini conference that's free, that's held by Michigan State University. It's their second year of doing it. It's very nice. It's organized by their new computational sciences department. And actually the week after that, October 10th and 11th, there'll be an academic medical forum, IT forum, held at the University of Michigan. I will also be there. You'll actually get a tour of our HPC data center that Monday, and that's also a free conference, so come by and see me there.
Cool. All right. Well, today, as you were talking about, this was a user-suggested topic, and I think we actually do have an award-winning category here because we have the most number of people we have ever interviewed at once. We have 4 people from this particular project. So, Brock, tell us what we got today.
Yeah, so we have a little bit of a dining philosopher's problem here with 4 guests plus 2 hosts on the phone. So this is the most we've ever done. Everyone's in a different location. But the guests today are representing the Julia project, julialang.org. Guys, why don't you go ahead and introduce yourself?
Hi, thanks for having us. So I'm Jeff Bezanson. Let's see, I recently finished a PhD at MIT. I'm mostly interested in compilers and programming languages, and I have a little bit of background in scientific and research programming. It's part of what got me started on this.
Hi, Alan Edelman here. Glad to be here as well. I've been a professor at MIT for 20 years in applied math and in computer science lab. And I'm interested in the whole range from numerical algorithms all the way to making scientific computing and technical computing run faster and easier.
Yeah, I'm Stefan Karpinski. I used to work as a data scientist. I learned MATLAB from Viral, who's going to introduce himself next. And we got into this because we felt like we could do something good for data science, something good for numerical computing, a language that we could use for all the things we like doing.
Yeah, hi, this is Viral Shah. I've known all these guys for a very long time now, and I personally have a PhD in computer science and computational sciences from the University of California at Santa Barbara. And, when we met up, we started talking about Julia, and this is, I come from the scientific computing world, and it's just what I love doing, and that's what all of us are doing today. So Jeff and Stefan and myself are also co-creators of Julia Computing along with Alan, but while Alan is still driving the research at MIT, the 3 of us are co-founders of Julia Computing.
Okay, so what exactly is Julia?
Julia is a programming language. It's a general-purpose programming language, but it was motivated by the kinds of problems that people have in technical computing. And the kinds of programs people write in MATLAB and Python, NumPy, and R. And we looked at that world and looked at our own experiences in it and decided that a new language design was really necessary.
The way I like to describe it is Julia is something like a Python or an R or a MATLAB when you first come to see it so that it's easy to start using. But under the hood, it's something very, very different. It's much more powerful.
Okay, so when you say it's something like these languages, what do you mean by that? Do you mean syntactically or grammatically, or what do you mean?
What I tend to mean is that when people come to Julia, they feel pretty much at home. They feel like they're ready to use it. Once you get past the square brackets or semicolons or a couple of other things, usually people are quite at home.
Yeah, sometimes people get hung up on one-based indexing and zero-based indexing, but like Alan said, it all sort of disappears in the background once you start using it.
So just for the record, which one are you, zero or one-based indexing?
There's a funny story there.
We are technically one-based indexing. We started out as one-based indexing, but today you can pretty much do much more than one-based indexing as of the latest Julia release.
My colleague Ron Rivest says that wars have been fought over lesser things. He thinks he has the solution. We should all go to one-half-based indexing and leave it at that.
That sounds like a perfect solution to me.
Yeah, I think that what Alan, to expand on what Alan's saying about people feeling comfortable, is that the syntax is superficially similar to MATLAB. So you can often translate MATLAB code to Julia just by changing a few parentheses to square brackets for indexing into arrays and not really changing too much else. But, the semantics are sort of closest probably to Python. It's very straightforward, dynamic language to use. But then there's sort of this rabbit hole of advanced features that you can go down that you don't need to know about right away to get into to write useful programs, but which can help you as you find yourself doing harder and harder things.
And indeed, what happens when you start to go down this rabbit hole is you become a better programmer, something that when you've used these other languages, you never knew you were missing and never knew you wanted to be. But then when you do it, you wonder how you lived without it.
Okay, so you've already mentioned Python and MATLAB, and we have Python and R as examples of open source as interpretive languages, as well as MATLAB as an example of a scientific but closed source one. So why do we need a new one?
Well, I think one thing is that to us, the key is to get the core abstractions really right. And also, to us, technical computing is largely about functions, essentially, and not just any functions. The functions that arise in this domain actually tend to be quite complex and have many definitions and many notions of them. And that's kind of what programs are built out of, and that's sort of what we observed. So we wanted a language that had a generic function-based paradigm rather than the popular class-based OO paradigm that's found in Python, for instance, which is good for many things. But we felt in this domain you really wanted generic functions where things are more function-based rather than object-based. Sure. So a generic function is a function that has many definitions. So basically, you add new methods to a function rather than adding it to an object. So you have a single function, and over time, as new types are defined or new cases are identified, you add other definitions to that function. And then when the function is called, there's a system for selecting which definition to call. Basically, it selects the most specific matching definition. So I was going to say it gives you roughly the same kind of dispatch of selecting different pieces of code that you get in object-oriented programming, but kind of turned in a different direction, where it's from a function perspective rather than from a kind of noun and object-based perspective.
If I could interject briefly regarding the broad question of why another language, there's two things I'd quickly like to say. One is that it's really not a competition. I mean, we're pretty friendly with the various other communities. We go to their conferences. They come to ours. But one rather different design that's worth bringing up is that languages like the ones we mentioned tend to be a kind of script over C or some other fast language, where while Julia does use other languages, it's primarily Julia all the way down. And that has very different implications.
So let's dive right into that. So that is the typical constraint, right? Is with NumPy and other things like that, you have nice abstractions in the target language itself, but under the covers, it very quickly turns into C for speed, or sometimes even Fortran, something that can be, utilized for its typically numerical efficiency in various types of computation. You mentioned two important things there. One, you mentioned the whole speed thing itself, and so we'd like to